We're going to talk reflections today. Reflections, also in simpler terms, is called like a flip. What I'm going to do right now is I'm starting with my shape, and this is a trapezoid. I know it's a trapezoid because it has one pair of parallel sides, and that's it. It's a quadrilateral with one pair of parallel sides. I am looking to reflect this trapezoid over this line right here. Reflect it or flip it. So basically what it needs to look like in the end is it needs to look like a mirror image. So before we even start, I can picture this and see what it should probably look like. If I flip this around, I can envision that it's just going to be kind of, rough draft. It's going to be kind of upside down, okay? But we need to figure out exactly what it would be and where it would be. So the easiest way that I've found to do this is I just take a ruler, and it doesn't matter what kind of measurement you use. I'll just use centimeters. I think that's easiest. And I take each, what we call vertex, each point here, and that's another word that we'll talk about later, but we might as well introduce it now as vertex. Each one of these vertices is the plural of it. Vertex would be one, vertices would be more than one, and figure out how far each one of these is from the reflection line. So if I hold this up here, it looks like from here to the reflection line, this is like 6 centimeters. Okay, so basically I'm just going to write from here to here is 6 centimeters. This one would also be 6 centimeters. The other two, if I hold this up here, that looks like 9 centimeters. Okay, so from here to here we would have 9, and from here to here we would also have 9 centimeters. Let me write that a little better because you can't really see it. 9, 9, 6. Okay. Now, all we have to do now is draw the line the same distance away from the reflection line. So we should have two dots that are 6 centimeters away from the reflection line. So if I put this on here, 6 centimeters away from the reflection line is going to be about right. And you want to make sure it's lined up with the dot here. We'll line it up right there. There's about 6 centimeters. Over here we'll do the same thing. We'll keep it in line with this dot right here. Line it up, and let's see, 6 centimeters is about right there. Okay. Now the other ones we have to do are going to be 9 centimeters. So I'm going to take this right here. It was 9 centimeters from there to there. So actually what I could do is I could just leave the ruler like this, and it's got to be 9 centimeters from here to here. So it also has to be 9 centimeters from here to here. So 9 here is going to be 18. So I could just come down here to the 18, and I can draw a dot right there. I could do the same thing over here. It's about 9 centimeters, and I'll come down here to the 18 because that would be twice as much, and I'll draw it right there. Okay. Now, as you can see, we've got our dots here. We've got one here that was 6, 9 from the reflection line, 9 from the reflection line, 6 from the reflection line. Now I have to do is connect the dots. So I can connect it there, 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 and across like that, and I've got my reflection of the trapezoid. All we really had to do was measure how far each vertice was from the reflection line and reflect it over. You just have to understand that when you're doing this, the points are going to be opposite of what you had before. So if I would label this A up here, A down here is going to be this one. If I labeled this B, B down here is going to be this one. C, reflection, D, reflection. So it's the same shape, it's just reversed, or it's basically upside down. All right, next example, we've got another quadrilateral. We've got a rhombus here. It's a rhombus because all the sides are the same length. We want to reflect this rhombus over this line right here. In order to do that, we have to find out how far each vertex is away from the reflection line and draw it the same distance away on the other side. So I'm just going to label these, basically, I'll just do the same thing. A, B, C, and D. and we know it's going to be the opposite when we put it on the other side. So let's measure and see how far apart these are from the reflection line. Again, I'm just going to use centimeters. So A to the reflection line is 7. Okay. B from the reflection line is 7. So I know that both of these are going to be 7 away, which means it has to be 7 away on the other side. D and C are both, looks like, 11 away. Okay, so I know D and C are going to be 11 away. So I've got a couple choices here. I could start at the reflection line, lining it up with that dot, and draw a dot that's 7 away. Okay, I could definitely do that. Let me get a better hold of this here. 7 away. Or I could start it at the dot and just double what I had. So if it's 7 away from here, that means it's going to be 14 all the way across. So I could put it on the 14 right there. I'll do the same thing. I'll come over here. Doubled is going to be 14. Now down here we've got to make it 11. Okay, so I could simply come down here. I just put it here. I could come down here and I could draw 11. Okay, or I could take it up here and line it up and draw it twice as much. Twice of 11 is going to be 22. So I could just take my thing here, put it on the 22. Same thing, I could come over here. It's 11 away from that reflection line. So I could just put it on 22. Okay. So now we've got our dots that we actually just need to connect to get our reflection of a rhombus here. So I'll just connect these dots. And now we've got the same shape reflected over this line. It's the same distance from here to here as it is from here to here. Now if you think about these points, A goes with A here. B reflected would be B here. C reflected would be here. And D reflected would be here. So all we're focusing on is making sure that each of the vertices, or each of the points, is the same distance away from the reflection line. This was 7, so this is 7. This was 11, so this was 11.